In this video, you will learn how to find the limit of trigonometric functions. So before to start, there are some important points to say. In this video, we will see some rules about sine, okay? And we'll see with those rules some examples, simple examples, and the same for cosine and the same for tangent, okay? Then we'll go to some more complex examples. For their proofs, for example, here when we say limit x approach to 0, sine mx is equal to 0, okay? Meaning, when we say limit x approach to 0 sine x, this is equal to 0, limit x approach to 0 for sine 2x is equal to 0, so no matter what you have here, and m can be equal to any number, m can be equal to -1, m can be equal to 1, no matter, okay? So no matter what you have here as numbers, so it is equal to 0 always, okay? Meaning the limit x approach to 0 sine x is equal to 0, okay? So those proofs, we might see their proofs, but in general they are not difficult to memorize, they are not too many, okay? So second rule is limit x approach to 0 sine mx over x, this is equal to m. Let's see this example. So sine of x over x, this is equal to 1. Sine 2x over x, this is equal to 2, okay? So we always look at this, m, okay? So you have here 1 and here is 1. Here 2, here is 2, okay? But for example, if you have limit x approach to 0 for sine of 2x over 2x, so when you have the same angles, here 2x, here 2x, okay, this is equal to 1 directly, okay? Let's continue. Limit x approach to 0 for x over sine nx, this is equal to 1 over n. Let's see this example. Limit x approach to 0, x over sine 3x, this is equal to 1 over 3, okay? So n here is 3, okay? Let's see this rule also. Limit sine x approach to 0, sine mx over sine nx, this is equal to m over n, okay? So we take the coefficients of x, okay? Here sine of 2x over sine 3x, so we take 2 over 3, okay? Let's see last rule here. Limit x approach to 0, x over sine x, this is equal to 1. So it is the same. The example is the same for the rule. So x over sine x, this is always equal to 1, okay? Now coming to tangent, tangent implies the same rules as the sine, meaning, so here we have tangent mx is equal to 0, tangent mx over x is equal to m. The same things apply. We saw that the same things applies to sine also. So what you do for the sine, okay, to find the limit, you do the exact same thing for the tangent, okay? So they are identical, we can say, while finding the limit, okay? Now coming to cosine. So cosine differs. We said that so the limit x approach to 0, cosine x is equal to 1, okay? No matter what you have as a coefficient for x, sorry, the same, another example for the same rule, limit cosine 2x, so limit x approach to 0, cosine 2x is equal to 1. So you see the coefficient here is 2, here is 1, okay? So this is equal to 1 and this is equal to 1. So no matter what you have here, okay? Then limit x approach to 0, 1 minus cosine of x over x, okay? This is equal to 0, okay? so you memorize it. In this way, in future, we might talk about their proofs, okay? Limit x approach to 0, cosine 2x, cosine over cosine 3x, this is equal to 1, okay? Finally, limit x approach to 0, x cosine of x over x, this is equal to 1. And another example, limit x approach to 0, x cosine of 2x over x, this is equal to 1, okay? So no matter what you have as a coefficient for x here, okay? Let's see first example with finding the limit. Find the limit as x approaches to 0 tangent to x over sine 3x. So if we substitute each x by 0, we'll get the division 0 divided by 0. This is indeterminate quantity and we have to avoid it, right? So what we will do is we'll divide each part. So we'll divide tangent to x by x, okay, over x, and we'll divide also sine of 3x over x. And we already saw the rules of when you have tangent of, we said tangent of m multiplied by x over x, this is equal to m, right? If we go back, you will see, so tangent of mx over x, this is equal to m. So you will do it in this way, okay? So here you get 2, okay? The m is 2 here, and the same for sine. We said what rules are applied for tangent. They are the same also applied for the sine. So here we take the me here is 3, so you take 3, okay? So the limit as x approach to 0 for tangent 2x over sine 3x is equal to 2 over 3, okay? Let's see second example. So find the limit as x approach to 0 for x plus tangent x over 2x plus sine x. So if we find the limit directly, we will get 0 divided by 0, and this is indeterminate quantity. We have to avoid it, right? So what we will do is we'll divide each term by x. So x divided by x plus tangent x divided by x over 2x divided by x plus sine x divided by x, okay? So this, we will do this simplification. This, we'll go with this, okay? And this x also will be removed, okay? This is equal to, here, x divided by x is equal to 1. 2x over x, so this x will go with x. You will get 2 here. And this, we won't touch it, okay? Tangent x over x, we didn't touch it. Sine x over x, we didn't touch it, okay? Then now we will find the limit. So find the limit as x approach to 0 for the same, this one, okay? So constant numbers 1 and 2, they won't be changed, they are the same, okay? Now tangent x over x, so this is equal to 1, and sine x over x, this is also equal to 1, and finally this is equal to 2 over 3, okay? Let's see third example. Find the limit as x approach to 0 for 2x plus tangent 3x over sine 2x. So if we substitute each x by 0 directly, so if we find the limit directly, we get the division 0 divided by 0, and this is indeterminate quantity, right? We have to avoid it. So what we'll do is, we'll do the same steps we did before. We'll divide each term by x, so 2x divided by x, tangent 3x divided by x, sine 2x divided by x. And this is equal to, so this x with this x will go, so we have 2 here. So tangent 3x over sine 2x over x, we didn't touch them, okay? Now we find the limit, so limit x approach to 0, so this one is here, okay? So 2 plus tangent 3x over sine 2x over x, so this is equal to 2 is a constant number, okay? So it won't be changed. Then tangent 3x over x, so this is equal to the limit of tangent 3x over x is equal to 3. Then the limit of sine 2x over x is equal to 2, okay? And this is finally equal to 5 over 2. Let's see fourth example. So find the limit as x approach to 0 for sine of x over the square root of x plus 1 minus 1. If you calculate the limit directly, you will get 0 divided by 0. And this is indeterminate quantity, right? So you have to avoid it by multiplying by the conjugate. So if you watched the previous video, we discussed how to find or you learned how to find the limit of a radical function when you have the square root of something, of x plus 1 here in this case. So what we do is directly you will multiply the numerator and the denominator by the square root of x plus 1 minus 1 in this case, okay? But you will multiply by the conjugate, okay? Just a quick reminder, we said the conjugate of a minus b is a plus b, okay? So what we change is only the sign. This means the conjugate. So in this case, we change the sign to plus, okay? Here is minus, we change it to plus. Second step is, we will multiply, so this multiplied by this, we didn't do the multiplication, we just put them together. Then this we take the difference of squares. So we already in previous videos also we explained the famous identities. You can click on this card here. I will make a quick reminder for you. So here it quickly is a minus b, so multiplied by a plus b. So this is equal to a squared minus b squared. So this is the same case. This is a, this is b, this is a, this is b. Here you have minus, here you have plus. The same case. So you take the square. So when you have the square root and you have the square here, this will remove this. So you get x plus 1. You see in this case, x plus 1. And the square of 1 is 1. Okay? And so 1 minus 1 is equal to 0. You have only x remains. And this we didn't touch it. Okay? This one we didn't touch it. So then we take this one. So we find the limit of as x approaches to 0 for sine of x or multiplied by the square root of x plus 1 over x. So we already saw that the limit as x approaches to 0 for sine of x over x, you see here, we take it like that. We take limit x approaches to 0 sine x over x is equal to 1, right? So that's why we get 1 here. Then the square, we substitute this x by 0. So we take the square root of 0 plus 1, okay, plus 1, plus 1. This is equal to 2, okay? So the limit of x as x approaches to 0 for sine x over the square root of x plus 1 minus 1. So this is finally is equal to 2, okay? Thank you for watching and hope to see you in the next videos.